Bassac River, Phnom Penh, Cambodia. Located at the intersection of the Changkarman, Meanchey, and Shperamp districts. There are two parallel bridges across the river. These are the Monivong bridges that connect the East Bank and the West Bank. These two bridges were not built at the same time. The North Bridge was built first. After that, Cambodia fell into a war for many years. It was not until the end of the century that the war gradually subsided. After entering the 21st century, the political situation became increasingly more stable. As the country developed, the original bridge became more and more congested. For this reason, in 2006, the government decided to build a new bridge south of the original one. The new Monivong Bridge was built to improve traffic. Overseas Cambodia Investment Corporation invited Vietnam-based Sino-Pacific Construction Consultancy to submit a tender, which they ultimately won, attaining the opportunity to take on this project. Since then, a journey of cooperation between two parties began. The Civil War caused a lag in Cambodia's development. Technical engineers and workers were hard to find. Most construction sites used outdated equipment. To this end, the project team explicitly introduced barges, drilling rigs, cranes, and other materials from abroad to bring into this project. To ensure the speed and quality of the construction of the new bridge, during the construction of the board pile foundation, the project team encountered a thorny problem. Some pile casings could not be placed on their expected positions. In order to understand the underwater condition, the project team not only performed further geophysical prospecting for the riverbed, but also searched around the vicinity. It was discovered that a steel bridge existed at this very location before. It eventually collapsed in the riverbed of the proposed construction area. A large-scale salvage effort would be necessary. If all the debris was to be cleared, this would affect the safety of the current existing bridge. The project team decided to move the location of the proposed bridge 15 meters south of the original proposed location, to avoid the debris and reduce the salvage range. In general, there were three types of debris to clean up. The first was the debris lying on the surface of the mud. Most of them were rebar, wire meshes, etc. The project team tied floating empty bottles to the debris, which helped mark the position, count the number, and recorded related information of the debris, and enabled the team to salvage them one by one. The second kind was the debris buried 3 meters below the surface of the mud. Most of them were steel frames, concrete plates, etc. It was necessary to pump the surrounding mud first in order to increase the exposed portion of the target debris before salvaging it. The third kind was the debris buried 6 to 7 meters below the surface of the mud. This was the enormous and heavy pier of the old bridge that collapsed before. The size and weight greatly increased the difficulty of salvaging. After 3 months of mud pumping and wreck lifting, the target wreck could only be lifted to a location away from the construction location. The salvage work was carried out step by step as planned. With the completion of the cleanup, all steel casings could finally be placed in their expected positions. The new Monivong Bridge was supported by 2 main piers. Each pier was composed of 18 piles with a diameter of 1.5 meters and a length of 40 to 60 meters. Each pile had a different length. This required the project team to keep performing the geologic drilling throughout the construction process, and substantially increased the difficulty of construction. As for the concrete needed for the construction of new Monivong Bridge, 3 features were required: workability, flowability, and retardability. Why was the workability of concrete required? In order to save costs, the project team installed the concrete delivery pipe along a temporary trestle. The concrete was delivered across long distances. During the construction of the bridge, the concrete had to be pumped across a considerable distance. This could only be accomplished by using concrete with good workability. Otherwise, the concrete could block the delivery pipe or even cause broken tiles. Why was the flowability of concrete required? The bridge rebar was densely arranged. If the concrete flow was insufficient, it would experience difficulty in vibrating and the surface of the concrete would appear honeycomb and pockmarked. It could even leave space inside the concrete and cause the separation of concrete and reduce its strength. Concrete with high flowability has the benefit of more effective concrete pouring. Why was the retardability of concrete required? The normal initial setting time of concrete is between 1.5 to 2 hours. This type of setting time cannot meet the needs of the bridge construction. At least 5 hours are required for the concrete pouring of one bridge pile. In case an extraordinary situation happens, it may even take up to 8 hours. While pouring concrete for the board piles and the box girders, cold joints can easily be created if the initial concrete setting time is too short. In addition to the aforementioned three features, both tensile strength and anti-sea racking properties are required. In 2017, the type of concrete needed for the construction project could not easily be found in Cambodia. In order to produce satisfactory concrete, the project team provided technology to support local concrete batching plants. By joining forces, the team performed repeated rounds of adaptation. For the supply of concrete, a strict system of tracking and managing was implemented by the project team. Delivery time, arrival time, waiting time, and pouring completion time were all carefully checked and inspected. If anything went beyond the allowable time, the entire load of corresponding concrete would be returned. As a critical and rigorous step of the process, no mistake was allowed. For the new Monivong bridge, the height of the bearing platform is 3.5 meters and the height of pier is 6.84 meters. For the construction of the bearing platform, the project team used the cofferdam for operation. The steel panels were utilized to fence in all sides and seal the bottom, to form an enclosed space with an opening on top. The weight of a completed cofferdam was up to 200 tons. There was no large hoisting barge ships available in Cambodia and RBY countries at that time. If one was imported from a country farther away, the longer distance would create higher expenditures. In order to reduce the cost, the project team chose to utilize manual chain blocks to lift the cofferdam down. If the tempo of lifting down by each chain block was different, uneven stress would be created. The project team proposed to install 28 12-meter-long rebar as bearing booms. In addition, this was used as a stuff gauge that provided assistance in lifting the cofferdam down. After all preparations were done, 60 workers under the command of one foreman lifted the cofferdam down in unison. After more than 20 hours of labor, the cofferdam was finally lifted down. The lowest water level of the Bassac River was 0.5 meters. The highest water level was 10.5 meters, making the water level drop up to 10 meters. The water velocity was about 1 meter per second during dry season and 2.5 meters per second during flood season. The water level rises at a speed visible to the naked eye. This construction was a race against time. Bridge construction is very dangerous work. surrounded by turbulent water. The available working area is narrow and congested. In order to enhance the safety of construction, 2 cradles were utilized in the new Monivong Bridge project. As no manufacturer in Cambodia could produce such a large piece of equipment at the time, the project team had to order individual customized parts from a factory in China, which was then delivered to the construction site in Cambodia for assembling. These 2 sets of equipment played a critical role in the construction speed and quality. The stress and strain on the completed part of the bridge during construction are deeply affected by the aquatic environment. During the construction process, it is necessary to accurately grasp the deformation value of the bridge at each stage, in order to close the bridge from both sides precisely. The project team assigned a commissioner to observe the construction. The first task was to survey the position and the changes of the structure, such as the elevation and location of box girders. The second task was to test the internal stress of the structure via embedded components, such as the stress of concrete, pre-stressed rebar, etc. This not only provided data for construction but also provided reference for predictive analysis. During the process of closing, the temperature must be controlled at 25 to 29 degrees Celsius by calculating the interrelation between elevation and temperature. In this particular location, this temperature range was best at night. When night fell, concrete pouring began. Working hard throughout the night, the bridge was finally closed smoothly. The remaining work was to build deck structure and auxiliary facilities, such as laying pavement, installing guardrails, and removing construction equipment, etc. After the bridge was finally completed, the whole of Phnom Penh was caught up in celebration. This construction was highly acknowledged by the government, the client, the consultant, and the local people. The ribbon-cutting ceremony of the bridge was hosted by Cambodian Premier himself, Mr. Hun Sen. A special medal was awarded to the General Director of Sino-Pacific Construction Consultancy at that time, Mr. Chang Pei. The success of this project established the confidence for both Cambodian government and Overseas Cambodia Investment Corporation towards Sino-Pacific Construction Consultancy. The Overseas Cambodia Investment Corporation and Sino-Pacific Construction Consultancy established Cana Sino Construction Corporation as a joint venture company in 2012. The personnel involved with the construction of new Monivong Bridge became the backbone staff of the new company. Under the effort and operation of these staff, the scale of the company began with less than 20 people in the beginning and increased up to near 200 people at present.